factoring useful. There are several ways to factor a polynomial. One of the ones that I like the best is grouping. Grouping helps you, especially when you're having a hard time figuring out the combination. Analyzing a visual model for polynomial factorization. Factoring a polynomial of degree n involves finding factors of a lesser degree that can be multiplied together to produce a polynomial. When a polynomial has degree 3, for example, you can think of it as a rectangular prism whose dimensions you need to determine. And let's hold it real quick. Let's see here. Factors. What are factors? When we say factors, well, remember, you got 2 times 3 equals 6. Well, 6 is the product, and 2 and 3 are the factors. So that's what you're looking for. You're looking for the 2 and 3. All right. And back to our problem here. The volumes of the parts of a rectangular prism are as follows. Red, the volume is x cubed. Green, the volume is 2x squared. Yellow, the volume is 8x. Blue, the volume is 4x squared. And the total volume is x cubed plus 6x squared plus 8x. So you got x here, and then you got x there, and you got x back, and this right here is 2, and that part there is 4, and whatnot. All right. The volume of the red piece is found by cubing the length of one edge. What is the height of that piece? So the height, what is it? Is right there. The height, x. All right. That's terrible looking. X. The volume of a rectangular prism is V equals length times width times height, where length L is the length and W is the width and H is the height of the prism. Notice that the green prism shares 2 dimensions with the cube. What are these dimensions? Well, they share x and x. What is the length of the third edge of the green prism? Well, it said the volume of the green prism was 2x squared, right? And right here we say it's x and x, so x times x. Well, that takes rid of that. That gets rid of that. And you're left with 2. And that's the length of the last edge is 2. You showed that the width of the cube is x, and the width of the green prism is 2. What is the width of the entire prism? X plus 2. You determine that the length of the green piece is x. Use the volume of the yellow piece and the information you have derived to find the length of the prism. Well, let's see. The yellow volume was 8x, right? You determine that the length of the green piece is x. Use the volume of the yellow piece and the information you derived to find the length of the prism. The height is x and the width is 2. So let's divide that by 2x, and we get 4. And so the remaining length edge is 4. And let's see if we can, this this was x, the height here. This length here was x. This part here was 2, so that would be x plus 2. And then this section, this was x by, and that right there is x. So this right here is the same. That's x. And then this side over here, we just saw 4. We found that it's 4, so you got x plus 4. Since the dimensions of the overall prism are x plus 2, and x plus 4, the volume of the overall prism can be rewritten in factored form as volume equals x times x plus 2 times x plus 4. Multiply these polynomials together to verify that this is equal to the original given expression for the volume of the overall figure. So we can do that real quick. Let's see here. You've got x times x plus 2 times x plus 4. X times x, that would be x squared plus 2x. And now let's multiply that times x plus 4. So that would be x squared times x. That's going to be x to the third. X squared times 4 would be plus 4x, and I'm just 4x squared. 2x times x would be 2x squared, and then 2x times 4 would be 8x. And these two here, they can be simplified. So that's going to, combined like terms, x cubed plus 6x squared plus 8x. And that should be what it said there to begin. What is one way to double the volume of a prism? Well, the prism was, it's not really straight. You've got, and we'll say this was x and that was x. You could double the height. That would double the prism. So double the height. Factoring out the greatest common monomial first. Most polynomials cannot be factored over the integers, which means to find factors that use only integer coefficients. But when a polynomial can be factored, each factor has a degree less than the polynomial's degree. While the goal is to write the polynomial as a product of linear factors, this is not always possible. When a factor of degree 2 or greater cannot be factored further, it is called an irreducible factor. I'll let you read A on your own, and when you come back, we'll do B together. We'll do B together. So we have 2x cubed minus 20x. Write out the polynomial. Screw this up a little bit. Write out the polynomial. So you got 2x cubed minus 20x. Now what's the greatest common factor of these two? X. So that gives you x times x squared minus 10. Why wasn't the factor x squared minus 10 further factored? Well, 10. What are the factors of 10? 10 and 1 and 5 and 2. Okay? Can we add or subtract these together and make it into 0? No. So x squared minus 10 is irreducible. Irreducible. It is irreducible. Consider what happens when you factor x squared minus 10 over the real numbers and not merely the integers. Find a such that x squared minus 10 equals x minus a times x plus a. That would have to be x minus the square root of 10 times x plus the square root of 10. That would be the only way that would work. Let's try your turn, number 4. You have 3x cubed plus 7x squared plus 4x. Now, what's the greatest common factor there? Well, they all got an x, so we can take an x out, and that gives you 3x squared plus 7x plus 4. Okay. Well, how can we reduce that further? 3 times 4, that's 12, right? Well, what are the factors of 12 that would give you 7? Well, 4 plus 3 is 7. So we can rewrite this as x times, and then we've got 3x squared plus 4x plus 3x plus 4. Okay, and if you look, the 4x and the 3x, they both equal 7x. Now that we've done that, let's group it. So we'll group the first two terms, and then we'll group the back two terms. So we've got x here, and then what can we pull out of here? They just have an x. That's all they have in common is an x, so let's take the x out. And we have 3x plus 4 plus, and what's the greatest common factor in there? 1. So we got 1. And then we're left with 3x plus 4. Now, this and this, they're the same thing, right? So we're going to end up with x times x plus 1, this term and this term, and then we've got the 3x plus 4 left. So now we have factored. Now we have factored that. Recognizing special factoring patterns. Remember the factoring patterns you already know. Difference of two squares, x squared minus b squared, perfect square trinomials, x squared plus 2ab plus b squared. There are two other factoring patterns that will prove useful. The sum of two cubes, a cubed plus b cubed, equals a plus b times a squared minus ab plus b squared, and the difference of two cubes, a cubed minus b cubed, equals a minus b times a squared plus ab plus b squared. Notice that in each of the new factoring patterns, the quadratic factor is irreducible over the integers. So go ahead and read A and follow along. And then when you come back, we'll do B. Glad you're back. So 8x cubed minus 27. First, it says write out the polynomial. So that gives you 8, let's see, x cubed minus 27. And notice that 8 and x cubed, those are perfect trinomials, and 27 is actually a perfect trinomial. Okay, 8x cubed equals 2x to the third power. 27 equals 3 to the third power. So what we have here is a difference of perfect cubes. Difference of perfect cubes. Difference of perfect cubes. So, and the formula from just above is a cubed minus b cubed equals a minus b. Well, in this case, a or 2x is the a. So we're going to have 2x minus, and the b is the 3. 2x minus 3. And that's going to give you, well, 2 squared. That's going to be a squared. So that's going to be 2x squared. That will give you 4x squared plus a times b. That's going to be 2x times 3. That's going to give you 6x. And then b squared, that's going to be 3 squared, and that's going to give you 9. The equation 8x cubed minus 27 has 3 roots. How many of them are real? What are they? And how many are non-real? So we have, remember, since the degree is 3 here, that means we're going to have 3 roots. 3 roots. We got 2x plus 3. That's going to be a real root. That's going to be a real root. And then let's see here. The next part was, let me do this in blue, do this in a different color. The next part from above, 4x squared plus 6x plus 9. Okay. Remember, we said earlier that would be irreducible over the integers. So if it's irreducible over the integers, you got to use the quadratic formula. A equals 4, B equals 6, and C equals 9. That 9 is still kind of ugly over there. Plus 9. All right. So we have x equals negative b. That would be negative 6 plus or minus the square root. And we're going to have 6 squared minus 4 times a, which is 4, times c, which is 9. And all of that's going to be over 2a, which in this case is 4. Now let's do a little arithmetic there. X equals negative 6 plus or minus the square root, and that's going to be 36. 4 times 4 is 16. 16 times 9. 16 times 9. 54. 9. 5 is 144. Minus 144 over 2 times 4 is 8. Well, what is that? That's going to give us a negative in here, right? Negative 144. So we've got x equals negative 6 plus or minus the square root of negative 108 over 8. The negative 108 in here will give us 2 unreal roots. 2 unreal roots. Or imaginary. Give us 2 imaginary roots. give us 2 imaginary roots. All right. Your turn. 6. You have 40x to the 4th plus 5x. Well, 5 goes into 40 and x goes in. So we can go ahead and factor out a 5x. And that's going to give us 5 goes into 40 8 times. X goes x cubed plus 1. Now, 8x cubed, isn't that 2x to the 3rd power? And then 1 can also be 1 to the 3rd power, because 1 times 1 is 1 times 1 is 1. So we've got, from up above, we have that formula a cubed plus b cubed equals, and that's going to be a plus b times a squared minus ab plus b squared minus. So how does this work out? So we get 2x plus 1 times, and then 2x squared would be 4x squared minus 2x times 1 is minus 2x plus 1. And then what do we have up here from earlier? So the final factors of all three, let's see, 40x to the 4th plus 5x equals 5x times 2x plus 1 times 4x squared minus 2x plus 1. So how many factors are we supposed to have? How many factors? So it says we'll have 4, right? 4 factors. The degree is 4, so we'll have 4 factors. 5x will be, that's 1 real. 5x would be a real. And then 2x plus 1, that will be a real. And then 4x squared minus 2x, that will give us 2 unreal roots. So this is 2 unreal roots. That's a factor, a real factor. And this is a real factor. For a total of 1, 2, 3, 4 roots, which is what this said we'd have. Factor by grouping. Another technique for factoring a polynomial is grouping. If the polynomial has pairs of terms with common factors, factor by grouping terms with common factors and then factoring out the common factor from each group. Then look for a common factor of the groups in order to complete the factorization of the polynomial. All right, take a look at A and then follow along. Stop the video and follow along. And then when you come back, we'll do B together. Glad you're back. So if you look, you got x to the 4th plus x to the 3rd plus x plus 1. And you notice the front two, they have a common factor. So we'll group those together. X to the 4th plus x to the 3rd. And we're going to group those together. And then what can we factor out of here? We can factor x cubed out of there. And notice that leaves you with x plus 1. What can we factor out of there? We can factor a 1. That's all we can factor. And that leaves x plus 1. So we have x cubed plus 1 times x plus 1. Now we have a perfect cube here, right? So we've got the x plus 1 there, the x plus 1. And if we factor this out, we're going to end up with x squared minus x plus 1. And then don't forget we got this right here, x plus 1. Remember it was a cubed plus b cubed equals a plus b times a squared minus 2ab minus ab minus ab plus b squared. All right, so that's it. And that's what we got. So now we're going to have x plus 1 and x plus 1. So that's going to be x plus 1 squared, x plus 1 squared. And then we've got x squared minus x plus 1. And those are the factors. Started out with 4, with a degree of 4. So we knew we were going to have 4 factors, and we do. We got 1, 2, and then in here are going to be 2 unreal. Let's take a look at 7 here. Your turn. Why don't you stop the video and try it on yourself, and then when you come back, we'll do it together. X cubed plus 3x squared plus 3x plus 2. And I'm looking here, and I've got x cubed. I can pull an x cubed out of there. So what do I got here? I got x squared, and that gives me x plus 3. Ooh, that's not going to work out too well. Let's try that again. So what do we got here? We got x cubed plus, how about x cubed plus 2x squared plus x squared plus 3x plus 2. X squared, 2x squared plus 1x squared, that's 3x squared. I've not changed anything. So now let's group these two here, and then we'll group that right there. Now what can we take out of here? We can take an x squared, and that's going to leave us with x plus 2. And then this right here is easy to factor. That's going to give us x that's going to give us x plus 1 times x plus 2. And then if you notice, we got this right here, and that right there is the same. So we're going to combine those right there. So we have x squared, and we'll make this x plus 1 because x plus 1 plus x plus 1, all of that, times x plus 2. Now, x squared plus x plus 1, that's irreducible. Can't do anything else with that. Solving a real-world polynomial by factoring a polynomial. Remember that the zero product property is used in solving factorable quadratic equations. It can also be used in solving factorable polynomial equations. Example 4, write and solve a polynomial equation for the situation described. I'll let you go ahead and read all that, and then when you come back, we'll do B together. Glad you're back. To build a hefty wooden feeding trough for a zoo, its sides and bottom should be 2 feet thick. and its outer length should be twice its outer width and height. What should the outer dimensions of the trough be if it is to hold 288 cubic feet of water? To build a hefty wooden feeding trough for a zoo, its sides and bottom should be 2 feet thick, and its outer length should be twice its outer width and height. So it kind of sets it up. Interior length, it says its sides and bottom should be 2 feet thick. Its outer length should be twice its outer width and height. So we're going to have 2x and then x and x. Okay, 2x minus 4. And if we multiply all these together, we get 2x cubed minus 16x squared plus 40x minus 32. And then we've got this 288. Subtract 288 from both sides, and you get 2x cubed minus 16x squared plus 40x minus, and then 30 and negative 288. That wasn't 30. That was 32. 32. 4 times 4 is 16 times 2 is 32. That gives you negative 320. And do a little group in here. Let's see. We got x squared and x to the third, and 2 goes into 16, so we got 2x squared. And then x minus 8 plus 40, and then 40 goes into 328 times. So we got x minus 8, x minus 8. It's going to be there. And here we're going to have 2x squared plus 40, so we can take a 2 out of that, and that gives us x squared plus 20, x minus 8. The only real solution is x equals 8. So the trough length is 16 feet long, 8 feet wide, and 8 feet high. Engineering. A new shed is being designed in the shape of a rectangular prism. The shed's side and bottom should be 3 feet thick. The outer length should be twice its outer width and height. What should the outer dimensions of the shed be if it is to have 972 cubic feet of space? So let's set this up. You got overall is 972, so we got 972 equals, and then what was it? The new shed is supposed to be it's supposed to be 3 feet thick. Its outer length should be twice its outer width and height. So that's going to give us 2x minus 3. And let's see, the shed side and bottom. Remember, volume is length times width times height. So we're going to have, and it said its length should be twice its outer width and height. So that's the 2x minus 3. And then we got x minus 6 and x minus 3. Shed side and bottom should be 3 feet thick. That's the 3 and the 3. its outer length should be twice its outer width and height. That's the 2x. All right, good. So that looks right. Let's do the arithmetic here. 972 equals, and that's going to be 2x cubed minus 24x squared plus 90x minus 108. Now we're going to subtract 972 from both sides, and that will equal 2x cubed minus 24x squared plus 90x minus 1080. 1080. Now let's see here. 2 goes into 24, and then x squared goes into x cubed. So we'll group these two here, and then we'll group those two right there. Because 90x and 90 should go into 1080. So what can we pull out of here? We can pull 2x squared, and that's going to leave x minus 12, and then 1080 divided by 90, that should be 12. That should be 12. So we've got plus 90, and that's a terrible looking, that might be construed as a 6, plus 90, and then we've got x minus 12. Okay, good. X minus 12 and x minus 12. So this becomes 2x squared plus 90 times x minus 12. X minus 12. And that equals 0, and 0 equals 2x. Can 2x squared plus 90 be factored anymore? So 0, let's see, 0 equals, and then we can pull a 2 out of there. We got 2, and then that's x squared plus 45. X squared plus 45. And then we have x minus 12. All right, x minus 12. Actually, this makes it kind of easy because x squared plus 45, that's irreducible. So your only real solution is x minus 12. The only real solution is x minus 12. So what do we got here? Our length is going to be 24. That's 2 times 12 is 24. And our width is going to be 12. And our height is going to be 12. Cool. Describe how the method of grouping incorporates the method of factoring out the greatest common monomial. Well, after you group into separate parts, you factor out the greatest common factor or greatest common monomial of each part to reveal a polynomial factor that is common to all. So let's write that out. After grouping, factor out the greatest common factor, and in this case here it would be a monomial. You can't really read that, can you? That would be a monomial. Monomial factor. of each part after grouping, factor out the greatest common factor or monomial of each part to find the polynomial factor that is common to all, common to both parts. And it's almost, unless it's irreducible, it is always the greatest common factor. How do you decide if an equation fits in the sum of two cubes? Well, if the first term is a perfect cube, and it is being added to a perfect cube, how do you decide if an equation fits in the sum of two cubes pattern? If the first term is a perfect cube and it is being added to a perfect cube, then it fits that. How can factoring be used to solve a polynomial equation of the form p of x equals a, where a is a non-zero constant? Well, subtract a from both sides. Sides to get p of x minus a equals 0. Essential question check-in. What are two ways to factor a polynomial? Well, grouping, and the other that we worked on is recognizing special factoring patterns. Grouping and recognizing special factoring patterns. And that's it, folks. Enjoy your evening, and I'll see you tomorrow in class.